Okay, welcome back. So now we study another rule called the cosine rule. In the cosine rule, what you have is you have a side, an included angle, and another side. The third side. Okay, so there's two situations. You need one of them. That's basically it. Okay, so what you see here is you're looking for, if we're in the paradigm of, let's say, the sine rule is great, and by the way, the sine rule is it's just a, one thing I didn't mention is that the sine rule is really the old definition of sine in a right angle triangle generalized. Because if you thought about the sine of an angle A is equal to opposite over hypotenuse. So you basically had, you see, you knew this was a right angle, so, and this is important that you knew this was a right angle, so there was two opposite pairs. Okay, so basically you moved that away and it didn't have to be a right angle, and there was still two opposite pairs. So if there aren't two opposite pairs involved, like we don't need this angle, we don't need this angle, then you either have three sides and you need any of the angles, or you have that little package there, that side angle side included angle side, and think of it as being, well, the worst thing I could put in the middle is A, but that's the way, look in the log tables, the way they give it is with C in the middle. So A, B, and C in the middle, and then a C out here. So let's go and do a little bit of a proof, and this isn't just a proof, this is a derivation. Okay, so we don't care what the rule is, let's explore what relationship we can generate from a triangle. So we shouldn't be aiming for the cosine rule, we should be aiming to explore trigonometry. And what we're doing is we're looking at what happens, our good old friend Pythagoras, for general triangles, because this is only for right angle triangles. So what happens to Pythagoras? That's the question. Turn to page 16. Not for the formula, but just for a bit of a visual here on a triangle, and say what's wrong with this triangle. Nothing. It's a beautiful triangle. Okay? But a lovely strategy is to always put the busy angle, the one we know, in the standard position. Okay, so when trigonometry grows up and we talk about getting the sine, cos and tan of angles bigger than naught, we needed to redefine what they meant, and we used the unit circle. Okay, well, a kind of a related topic is the coordinates. So think of a length here B, and think of drawing this circle here around the origin. Well, the coordinates of the points P on that circle are of huge interest to us here. Okay, so we have some length here C. So all I've said is I take that triangle I showed you a moment ago and we put it in a standard position. Just want to keep it exactly the way it is in the tables for no bloody good reason, only the angle is angle A. Yeah. So the angle is angle A. So C runs this way and B runs this way. A, B, C. So go A, B, C. I'll start that again. A long length, a shorter length of any particular shorter length, like so. Well, guys, if you want to draw this really nice, and forgive me for wasting so much paper, but if you want to say, I like the same picture every time, you might be like that. You just might want to kind of nail it down. So in that case, you'd work in pencil, go to a working line, okay. You draw your circle for B, and just for the hell of it, you'd go the exact same amount again, just because you'd have that on board, and you would take some point here, P. Okay, forgot to mark the center of my circle. That's okay. Now I have it. Okay, so I would draw in this length B, and this length is C. So we start putting in coordinates, C0, and this is B cos of angle A, and this could be anywhere at all in the circle. Now of course the triangle would be inverted downwards if it was pointing downwards, but that's okay too, that can happen. Okay, and it can be an acute or an obtuse. But any of the stuff that goes on down here in these two quadrants is congruent to what goes on above, so we do rule this out more or less without loss of generality. Now, the crux of the whole thing, this proof, is based on this side here. Let's put it in double just to highlight it. And it's still using Pythagoras, and using the distance formula, which is based on Pythagoras. So you have B cos of A, B sine of A up here. So you apply the distance formula. This length here is A, and you go ahead and you apply the distance formula. So A squared will be equal to, and let's start here, that, take away that, to be squared, and that, take away nothing, to be squared, plus here, I have to say all to be squared because I have to square both of the factors. Okay, that is B squared cos squared A minus 2BC cos A plus B sine squared A. Now a quick little reminder in our unit circle that we use for defining we use this to define sine and cos. So this is a unit with one here. The definition of sine of theta is this, and the definition, that height, and the definition of cos of theta is this. Definition, mind you. Okay, so we've thrown out the trig ratios from right angle triangles, and we said sine of theta and cos of theta exists for all angles. Not just up to 360, but coterminal angles as well, where you go around full circle. So if that's in the ordinary position and that's a terminal, well, and that's the angle, well, a coterminal angle would be that much. Okay, but in the case of a triangle, you don't have to worry about coterminal because they're restricted in their angle. So you only have to worry about from 0 to 180. So you only have to worry about the acute and the obtuse. So, but the point about all of this that I started talking to you about this down here is, well, if this is 1, then 1 squared equals sine squared plus cos squared. And this is an identity that you have to prove on the vast majority of maths courses. You'll have to prove it in your course that you're doing right now. So we need to know this, and it's called a Pythagorean identity. It's an identity because no matter what angle you put in, this is true. This is always true. This isn't an equation you need to solve. This is an identity. You can rest assured it's true. So we're going to operate and use this identity here by observing that we can factorize out b squared from these two terms. That's supposed to be b squared, and you get cos squared plus sine squared remaining. Now we also left out something here. We left out a c squared here during the squaring, and that's okay. I'll drop it in here. And now we have b squared cos squared plus sine squared that's that and that used, we have plus c squared minus 2bc cos of a. So we can kill that because it's 1. It's the multiplicative identity. So it's multiplying by 1 is the equivalent to doing nothing when it comes to multiplication. Just like adding 0 is the additive identity. And you get b squared plus c squared minus 2bc cos of a. But this is a squared, and we've pretty much given us our, that's it, there's your identity right there. Okay, and lo and behold, that's exactly what it says here in your tables. Whoops, I don't want to write that. Okay, cool. So are we done? No, not yet. Let's do some more algebra. We're not happy yet. So, but we have, and let's try and see, how do we write this from scratch? So first of all, I said it's going to replace Pythagoras. So what was Pythagoras about? Well, if I had a, b, and c here, you'd go a squared equals b squared plus c squared when you're writing out Pythagoras. Okay? But now we said that we don't care if that's a right angle or not. And there's nothing particularly special about a. It doesn't have to be the longest side or anything, while it does in the Pythagoras situation. So pick any angle you like. Okay? Any of the letters that represent a side. Write down the other two angles squared. At that stage you've got to Pythagoras, and now we have this corrective term. The corrective term either makes things longer than they would have been if this was a right angle, or they make things shorter, or they leave things alone. And we'll see how they all work. So you know that it's a minus in here because that's what we got when we derived it. We remember the cross product for squaring this up ended up being doubled, being doubly negative. So we ended up minus 2 times that by that, times the cos of the angle between them, the included angle. So the square of a side is equal to the sum of the squares of the other side minus 2 times the cross product of the two sides involved, the two other sides, times the cos of the included angle. Great. Now if the included angle is 90 degrees, the cos of 90 degrees is 0, and this corrective term is gone. So that's a lovely case. Okay. If this angle is larger than 90 degrees, cosine is negative in here according to cast, because cosine is positive here and here. Cast. Okay, so if it goes, because what you might be thinking is the corrective factor is going to make things smaller, but this is clearly getting bigger. But we end up with a minus times a minus is a plus. So as you go into the obtuse situation, you have a positive correction. And as you move back into the acute situation case, you have a negative correction, because cos is positive, therefore this is a negative correction, which is what you expect. So it looks great. So rearranging for other letters is really, really simple. You can just go b squared is equal to the square of the other two minus, and then you can just focus here on what you've just been writing, minus their cross product times the cosine of whatever is not here. Whatever is not here at all, whatever is here goes on here, and so on. So I can give you any 3 letters and you should be able to write out the cosine rule. Let's test you on that. I'll give you the letters P, N, and T, and I'll tell you to kick it off with T squared. So you can pause the video now and try and write that out based on these. By the way, sorry, when you start off with T squared, you will also be wanting the angle T. Okay, pause and go for it. So what you did there was you went T squared is equal to side length P squared plus side length N squared minus 2pn times the cos of the angle associated with that. Okay? But there's something else we need to do. We need to get the angle on its own. Okay? So we need to make this the subject of the formula. Let's go back to the way it looks in the tables. A squared equals b squared plus c squared minus 2bc, the cos of a. And what we end up with here is not in the tables, but it's really important that you have this sense of, because we're moving in now to proving and proving identities and deriving others. We're moving into the really powerful area of the deductive powers of mathematics and how trigonometry creates identities and formula for us equations that are always true. And these are no joke, they're really important in mathematics. Okay, so basically here we want to begin that journey by rearranging this. The truth be told, you don't have to formally know this. However, if you don't and you go to this as your starting point, you're going to be crippled with arithmetic that will slow you down. So the approach, especially at higher level, is to know the manipulated form of this in terms of angle A, and sometimes indeed cos of A. So what I would say is let's address this as term 1, term 2, term 3 and term 4, and let's isolate term 4. Okay. So the technique you're using, you're solving for A using the most basic technique of algebra, the one you use in linear algebra, which is to isolate. You're not using a formula in itself, you're not like you'd use the minus b formula, and you're not using a factorization or a technique like that. Okay, so you're trying to isolate letter angle A. So the first test you do is you isolate the term that it's within, and it's negative and you don't like that. So that's the driving force behind the direction, so we'll take that this way and call it 2bc the cos of A because it's become positive. And then this guy has to get the boot. Okay, so the odd one out is when in terms of adding and subtracting a square plus a square minus a square, the odd one out, the negative one, is the one associated, the side opposite the angle you're interested in. The next thing we do is, now that we have this term, we get rid of factors that are unwanted. So we'll drop down to 2bc by dividing. So we've b squared